Let's practice dividing fractions, whole numbers, and mixed numbers together. In number 1, we have 5/8 divided by 1/8. Now keep in mind, if we are talking about just dividing two fractions that have numerators and denominators, right away what we can do is we can keep the first fraction, we're going to change the division to multiplication, and then we're going to flip the second fraction upside down, or we're going to find its reciprocal. Okay, so if we keep the first fraction, that's going to stay as 5/8. If we change division to multiplication, and then we are going to flip the 1/8 to make it 8/1. This will be the new problem, but now it's a multiplication problem. So we keep change flip, or we can also consider this as multiplying by the reciprocal of the second fraction. Okay, at this point, you can do a couple of different things. You can go ahead and show the cross canceling if you would like to. So I'm going to go ahead and say 8 and 8. If you cross them out and divide them both by 8, you get 1 and 1. On top, 5 times 1 is going to be 5, and on bottom, 1 times 1 is going to be 1, and 5/1 is just going to be 5 wholes. Okay. And if you wanted to use prime factorizations instead of cross canceling, you can take the 5 and leave that alone here. The 8 you can break into 2, 2, and 2. And on the bottom, the 8 can break into 2, 2, and 2. And we have that 1 there. So you can notice here that these 2's cancel out, these 2's cancel out, and these 2's cancel out. So either way, you're going to still end up with 5/1, which checks out with what we got using the cross canceling method. All right, so there's number 1. For number 2, let's check this one out. We have 9/10 divided by 1/10. So we're trying to see how many 1/10 can fit inside of 9/10. We're going to keep this one the same, change the division, and flip this upside down. So we're going to basically multiply by the reciprocal. So we're going to keep this one, change division to multiplication, and then flip 1/10, or write its reciprocal, which is 10/1. At this point, I'm going to cross cancel these 10s. They both can divide by 10, so we get 1 and 1. 10/10 is just 1 whole. Then 9 times 1 on top is 9. 1 times 1 on bottom is 1. This simplifies down to just being 9. All right, so 1/10 fits into 9/10 9 times. Now, if you want to see the prime factorization method because you feel more comfortable, then the 9 breaks into 3 times 3, and the 10 breaks into 2 times 5. And the 10 on bottom breaks into 2 times 5, and you have this 1 here, but it doesn't really matter. Then you can see here that this 2 and this 2 will cancel, and this 5 and 5 will cancel. So we're left with 3 times 3 on top, which is 9. We're left with a 1 on bottom, so this still ends up being 9, so this hopefully still makes sense. Okay. If you take a look at number 3, we have 5 divided by 1/4. So we got to keep this 5 and rewrite this. I'm going to go ahead and write it like this, though. This 5 is really 5/1, and we're going to divide that by 1/4. Right? Now, we just had to rewrite that 5 as a fraction, so 5/1. Then we're going to go ahead and keep this, change this, and flip this. Now, if we go ahead and do that, we're going to keep the 5/1 as 5/1. Then we're going to change the division to multiplication, and then flip the 1/4 to 4/1. That's the reciprocal. And then it doesn't look like we can cross cancel, so 5 times 4 is 20, 1 times 1 is 1. 20 wholes, or 20/1, is just 20. All right. Now, if you happen to do the prime factorization method instead, you're going to notice that the 5 just stays as 5, the 4 breaks into 2 times 2, and you're left with a 1 times 1 on bottom, so nothing can cancel. So you're still going to get 20/1, or 20. All right, so either way you do it is fine, and notice there's no cross canceling, so it didn't really matter. Okay, moving on to number 4. For number 4, looks like we have 12 divided by 3/4. Okay, so let's go ahead and just rewrite the 12 first as 12/1 divided by 3/4. Let's start with that. And then if we keep this one and then change this and flip this, or change this to a multiplication problem and multiply by the reciprocal of the second fraction, then we'll have 12/1 times 4/3. All right, now if we take a look at this, we can cross cancel the 3 and the 12. We can divide them both by 3, that's their GCF. 12 divided by 3 is 4, 3 divided by 3 is 1. And then we're left with what's 4 times 4 on top, that's 16. And on bottom, 1 times 1 is 1. 16/1 ends up just being 16. Alrighty. Now, if we take a look at maybe using some prime factorization and decompose these or break them down a little bit, the 12 would break into 2, 2, and 3, and the 4 would break into 2 and 2. And on bottom, we have 1 and 3. Looks like we can cross out these 3's that they have in common. And then on top, 2 times 2 is 4, times 2 is 8, times 2 is 16. So 16/1 is definitely still 16. Okay. Moving on to number 5, we have 9/8 divided by 3. So let's just go ahead and rewrite this. We have 9/8 divided by 3, but as a fraction, 3 is 3/1. So this is the same problem, but now that we have a numerator and denominator for both fractions, we can keep, change, and flip. So if we keep 9/8, that's going to stay as 9/8. Change division to multiplication and flip the 3 and the 1 to make 1/3. That's the reciprocal. Okay, and we can now multiply these fractions. Now, when we're multiplying fractions, you can cross cancel. You can divide these both by 3 and get 1 and 3. And then on top, 3 times 1 is going to be 3, and on bottom, 8 times 1 is going to be 8. And since 3 and 8 are relatively prime, then we must be done here. All right. Now, if you wanted to use prime factorizations instead, feel free to. The 9 on top is going to be 3 and 3, and we have a 1. And the 8 on bottom becomes 2, 2, and 2, and the 3 that we had earlier is still there, it's prime. And so one of these 3's will cancel out with one of these 3's. On top you have 3 times 1, which is 3, and on bottom you have 2 times 2 times 2, which is 8, and so this gets you the same fraction. All right. Moving on to number 6, we have 15/8 divided by 9/4. So this one, I think we can actually just go ahead and keep, change, and flip right from the beginning because we already have a top and a bottom for both. So we can rewrite this as, 15/8. We're going to keep that, and then we're going to change division to multiplication, and the reciprocal of 9/4 is going to be 4/9. Okay, at this point, we're going to look for some cross canceling. I really like this 4 and this 8. I think their GCF is 4, so you can divide them both by 4. 8 divided by 4 is 2. 4 divided by 4 is 1. And then looking at this 9 and 15, I think you can divide them both by 3. That's their GCF, so 9 divided by 3 is 3. 15 divided by 3 is going to be 5. All right, so now on top here, I think everything's relatively prime with everything on bottom, so 5 times 1 is going to be 5. And then on bottom, 2 times 3 is going to be 6. So I'm getting 5/6 here for our quotient, or the answer to this division problem. All right, if we wanted to try using prime factorizations, we are going to go ahead and do that here. 15 is the same thing as 3 times 5, and 4 is the same thing as 2 times 2. The 8 on bottom is 2, 2, and 2, and the 9 on bottom is 3 and 3. All right, so this 2 and 2 we can cross out. Another pair of 2's we can cross out, and then a pair of 3's we can cross out. So on top we're left with 5, and on bottom we're left with 1, 2, and 1, 3, which makes 6. So we get the same thing both times, so I'm pretty confident about these answers, or these quotients. All right, moving on to number 7. Okay, number 7, we have 20/21 divided by 15/4. Okay, so we do have a top and a bottom for both, a numerator and denominator. So let's just keep, change, flip right from the beginning. If we keep the first fraction, that's going to be 20/21, and then we change division to multiplication, and then we flip the 15/4 to make 14/15. So we're multiplying the first fraction by the reciprocal of the second fraction. Now I'm looking at this 14 and 21. You can divide them both by 7. 14 divided by 7 is 2. 21 divided by 7 is 3. Now for 15 and 20, I think their GCF is 5. Dividing 20 by 5, we get 4. And dividing 15 by 5, we get 3. And I think that is it, right? So on top, 4 times 2 is going to be 8. And on bottom, 3 times 3, that's going to be 9. So 8/9 would be our final answer here. All right, if we wanted to use some prime factorizations, once we turn it into a multiplication problem, feel free to do so. 20 is 2 times 2 times 5. 14 is 2 times 7. The 21 is 3 times 7. And the 15 is 3 times 5. So if we go ahead and cross out the 7's, we can do that. The 5's, we can do those. And I think that is it. So on top, 2 times 2 times 2 is 8. And on bottom, 3 times 3 is 9. So we get 8/9 again. All right, so that works out nicely. Moving on to number 8, we have a whole number divided by a mixed number. So let's go ahead and rewrite this. So 9 is the same thing as 9/1. And then we're going to divide this by, we're not changing the problem yet, this 2 and 1, 7. So 2 times 7 is 14, plus the 1 on top makes 15. So this is the same thing as 15/7. All right, so our goal is just to rewrite the problem so it has a top and a bottom and a top and a bottom. And then we're going to keep this, change this, and flip this. All right, so what's our new problem going to look like? I think I'm just going to write it below here just to save some, we have the space we can use. So I'm going to keep this, so it's 9 over 1, change division to multiplication, and reciprocate the 15 over 7 to make 7 over 15. All right, I think we can cross cancel. The 7 doesn't have anything, but the 9 and 15, you can divide them both by 3. That's their GCF. Divide that by 3, you get 3. Divide 15 by 3, you get 5. And then on top here, 3 times 7 is 21. On bottom, 1 times 5 is 5. And you can also turn this into a mixed number. 5 fits into 21 4 times with 1 left over. So it's going to be 4 and 1/5 rather. All right, so you could say 21/5 if you wanted your answer as an improper fraction, or you can say 4 and 1/5 if you wanted the mixed number version. Okay, if you wanted to use prime factorizations, then it would look something like this. The 9 on top breaks into 3 times 3, and the 7 is prime, so it stays. There's a 1 here, and then we have 3 times 5 for the 15. And then these 3's are gonna cancel out with each other. And then on top, 3 times 7 is 21. On bottom, 1 times 5 is 5. So you can see this does work out as well. All right, moving on to number 9, we have a mixed number divided by a whole number. And so we want to rewrite this using just having numerators and denominators, so proper and improper fractions are fine. So 5 times 5 is 25. 25 plus 3 is going to be 28. So I'm going to write 28 over 5 divided by 15, but 15 as a fraction is 15 over 1. All right, at this point we have a division problem that we can keep and change and flip. And so if we go ahead and do that, we keep the 28 over 5. I'm going to write 28/5, change division to multiplication, and reciprocate the 15 over 1 to make 1 over 15. All right, so unfortunately, it looked like we were maybe about to be able to cross cancel that 5 and 15, but don't be tempted to do that when we have a division problem. We can only cross cancel when it's multiplication. So at this point, I don't see anything in common. 28 doesn't have any common factors with 5 or 15. So since everything is relatively prime here, 28 times 1 is 28, and 5 times 15 is 75. I think that's going to be it. And so we can go ahead and say that would be the final answer, or the quotient. Okay. If you want to see, why you can't actually cancel anything out, seeing the prime factors I think is super helpful. So 28 is 2, 2, 7, and the 1 stays. The 5 is prime, and 15 breaks into 3 times 5. And notice they have nothing in common, so you end up just multiplying everything back together to get 27 over 75. So that's why we can't simplify anything. It's just because they had no common prime numbers, or prime factors rather, right? Moving on to number 10, we have a mixed number divided by another mixed number. So let's go ahead and rewrite this first. So 1 times 8 is 8 plus 7. 8 plus 7 is 15. So we have 15 over 8 divided by, and we have to turn the next fraction into an improper fraction as well. So 2 times 12 is 24, plus the 1 on top is going to be 25. So it's going to be divided by 25 over 12. Now we have a top and a bottom for both, so we can keep, change, and flip and turn this into a multiplication problem. That's our strategy here. So keep the 15 over 8, change the division to multiplication, and then flip the 25 over 12 to make 12 over 25, or reciprocate it, okay? We can go ahead and cross cancel. It looks like the 15 and 25, we can divide them both by 5. 15 divided by 5 is 3. 25 divided by 5 is 5. And then the 12 and 8, I think their GCF is 4, so 8 divided by 4 is 2, and 12 divided by 4 is 3. I don't see any other common factors. I think everything's relatively prime between the top and the bottom. So on top, 3 times 3 is 9, and on bottom, 2 times 5 is going to be 10. And so that's a proper fraction, so we know we are done right away. Now, what if we used prime factorizations? So if we go ahead and take a peek at this, 15 would be 3 times 5, and 12 would be 2 times 2 times 3. The 8 would be 2 times 2 times 2, and 25 would be 5 times 5. Now, I think these 5s would cross cancel, these 2s would cancel, and another pair of 2s would cancel. So the only thing left on top is 3 times 3, which is 9, and on bottom you have 2 times 5, which is 10. So this would be our most simplified answer. For number 11, looks like we have another mixed number divided by another mixed number. So let's turn them into improper fractions first. So 6 times 10 is going to be 60, plus the 3 here is going to be 63. So the first mixed number is the same thing as 63 tenths. And then the second mixed number, let's see, 1 times 25 is going to be 25. 25 plus 17, I think that's going to be 42. So the second mixed number is going to be 42 over 25. All right, so now we have two fractions that have a top and a bottom and a top and a bottom, or they're both improper fractions. We're going to keep, change, and flip and turn these into multiplication problems. So let's go ahead and write 63 over 10 multiplied by 25 over 42. Okay, now if we see some cross canceling, this we can divide by 5 and get 2. This we can divide by 5 and get 5. And then when it comes to 63 and 42, you can divide them both by 21. If you divide 63 by 21, you get 3. And if you divide 42 by 21, you get 2. I think at this point we are all done. It looks like everything's a prime number and none of them go into any of the other ones. So on top 3 times 5 is 15, and on bottom 2 times 2 is 4. So you could totally leave your answer like this if there's no directions that say otherwise, but you can turn it into a mixed number as well and say 4 fits into 15 3 times. 3 times 4 is 12, so that's 3 away from 15. So 3 3/4 would be another way you could write this answer. Okay, if we were using prime factorizations, you could go ahead and break these numbers down as well. So 63 breaks into 3 times 3 times 7, and 25 breaks into 5 times 5. 10 breaks into 2 times 5, and 42 breaks into 2 times 3 times 7. If you're looking for things that we can cross out, looks like this 5 and 5 we could do that, this 7 and 7 we could do that, and I think we have a 3 and a 3. So on top, 3 times 5 is all we have left, it's 15, and on bottom 2 times 2 is 4. So I think this is exactly what we were looking for. Finally, for number 12, we have one more mixed number divided by another mixed number. So these require a little bit of work, but 3 times 15, let's turn this into an improper fraction. 3 times 15 is 45. 45 plus this 4 should be 49. So we have 49 over 15. And then we're going to divide this by, let's see here, 3 times 20 is 60, plus the 3 on top makes 63. So this is going to be 63 over 20. Now that we have a division problem where we have just numerators and denominators, no mixed numbers or whole numbers or anything like that, we can keep, change, flip, and turn this into a multiplication problem. And so if we keep the first one, that's going to be 49 over 15 still. If we change division, that's going to be multiplication. And if we reciprocate the second fraction, the 20 is now on top and the 63 is now on bottom. Look for cross canceling now that it's a multiplication problem. 15 and 20 can both divide by 5. That would be a 3 if we divide by 5, and 20 divided by 5 is 4. And then for 49 and 63, I think you can divide them both by 7. This would be 7. Divide this by 7, and that would be 9. I don't think anything else has common factors, so on top 7 times 4 is 28. On bottom 3 times 9 is 27. So this would be one way of writing our answer. It's an improper fraction, which is fine. But you can also turn into a mixed number, say this is 1 and 1/27, right? That's just the mixed number version of the answer here. Now, if you just want to see what this would look like using prime factorizations, 49 breaks into 7 times 7, and 20 breaks into 2 times 2 times 5. And the 15 on bottom breaks into 3 times 5. And the 63 breaks into 3 times 3 times 7. So notice how these 7s can cancel out with each other, these 5s can cancel out, and I think that's it. On top, 7 times 2 times 2, that should be 28. Yep, 2 times 2 is 4, 4 times 7 is 28. And on bottom, 3 times 3 is 9, 9 times 3 is 27. So we get the same improper fraction version as earlier, so this checks out. All right, so there you have 12 different practice problems on dividing fractions. Keep in mind that when you're dividing fractions, we would really like to just turn them into multiplication problems. So convert anything to improper fractions first if you have mixed numbers or whole numbers, and then keep, change, flip, or you can also more technically say multiply the first fraction by the reciprocal of the second fraction. Check to cross cancel or use prime factorizations by decomposing, and go ahead and see if you can find out that answer. The answer to that multiplication problem, after you've changed it, is the same answer to the original division problem. So If you found this video helpful, please consider giving it a thumbs up, and as always, keep up the great work, and I'll see you in the next one.